So, I made a program that takes a video and recreates it pretty well in a Geometry Dash level. I think the way it works is pretty interesting and unconventional, and the result looks quite a lot better than you might expect. But before you can recreate a whole video in Geometry Dash, we need to be able to recreate a single image. So, the task is simple. You have an image, and you have to recreate it in a Geometry Dash level using as few objects as possible. You will see why this is important later. The first solution that might come to mind is to go through every pixel in the image one by one and to add one square object for every single pixel with the same color as that pixel. Since you can only have 1,000 color channels in a level and you probably have more than 1,000 pixels, you might have to use the hue, saturation, brightness sliders instead, which can be set for each object individually. Other than that, you shouldn't have any problems if you ignore the fact that this uses like a jillion objects for a decent quality image. I mean, an image this crappy already uses 37,000 objects. And guess what? Geometry Dash can't even render that many objects at once. So you'll pretty much just get half a shitty image and some lag. The problem with this strategy is that we barely use any of the tools we have available. I mean, we only used one type of object and put a color on it, while we could be using any of the other 1,000 types of objects as well. This strategy doesn't use rotation, scaling, or opacity either. Imagine if you were to recreate this image. You could go through every single pixel, but the best solution is obviously just to recreate it with a couple of objects like this. Now, we could just go through every possible combination of objects until we find the ultimate unique set of GD objects that optimally replicates our target image, but that would take like longer than the remaining lifetime of the universe. We don't really need a perfect solution, we only need one that gets better and better the more objects we add. Are you thinking what I'm thinking? That's right, evolution. Hear me out. Look at this chameleon and ask yourself, is it perfect? The answer is no. Nobody's perfect, but this chameleon is pretty good. I mean, it can catch flies with its giant tongue, it can move both its eyes independently to look for predators, and it can change color to hide from them. It's not perfect, but it's still good enough, just like what we want our image to be. And how did it get this imperfectly good? Evolution. So one time, like 100 million years ago, right before 2.1 came out, an ancient ancestor of our chameleon was born with a freaky gene mutation. It could change the color of its skin. Or probably part of its skin. Probably just a few cells. Either way, one day, while enjoying its chameleon life, it is spotted by a predator. A huge, scary bird, probably. As the chameleon sees the bird dive towards it, it thinks to itself, "This is it. My life has led up to this moment. All my companions who ridiculed me for my skin defect. All the ones who rejected me. If only they could see me now." And as the bird lands, looking around for the lizard shape it saw a moment ago, it finds itself at a loss. For the chameleon has become one with the background, invisible against the flora, saved by its mutation. Meanwhile, at the other side of the forest, another bird sees another chameleon. However, this one does not have the color-changing skin, and it therefore gets eaten. The chameleon that survived lives on and has children, some of whom inherit the color-changing skin. The children of the other chameleon would probably not get the color-changing skin, but that doesn't really matter because that chameleon was brutally mauled by a bird and will therefore not have children. Because the color-changing skin makes you more likely to survive, it has now become more common, and after a while it will be the majority. This is just what we need, a process that naturally makes things more awesome. Can you really look into these sincere, independently moving eyes and tell this chameleon that it's not awesome? So, let's use this to create images in Geometry Dash. To make our image improve itself, we have to make better traits more likely to survive. Let's start by creating a couple of thousand random Geometry Dash objects. These are the creatures that we will adapt through evolution to make up our image. To make better objects more likely to survive, we have to define what makes an object good. In this case, an object is good if it contributes to making our current image closer to the target image. If we check the color difference per pixel between our current image without our object and our target image, and then check the color difference between our current image with our object and our target image, and then get the sum of all the differences between those two values for all the pixels, we get a measure of how much closer this object brings us to our goal. We'll measure this for all the random objects we made, and then we let evolution do its thing. We will let the top 100 or so objects live, while the objects that don't fit all die, they get eaten. The ones that are left, the ones that fit well enough into the image to hide from the bird, reproduce and make some children, each one quite similar but a little different from its parents. Now we have a new list of objects, the children of the winners from the previous generation, and we can start the process again. Measure how well they fit, get rid of the bad ones, let the good ones reproduce. After a couple of rounds of this, we pick the best object we found yet, and add that to our current image. We have now got one object in our image. Now we can just keep doing this for as many objects as we want until we like the results. So I made a program that did exactly this, and I'll give some more details on how exactly I programmed it later, but here are some examples of how it works in action. This is a time lapse of the program generating the image. Each object that gets added here has gone through that whole process and won the competition against thousands of other objects. Notice how it likes to start with large objects that cover a large area, and then as the current image gets more and more similar to the target image, it starts adding smaller and smaller objects to fill smaller and smaller details. And to be clear, I didn't program this in. This is just a natural result of the way it works. At the start, since the current image is so far from the target image, most of the pixels we change with our object will have a positive effect. So big objects will almost always get a better score, since they just have more pixels. However, when we get closer to the target image, adding large objects might screw up a lot of the pixels that we already have correct. And so it's better to add small changes that we know won't destroy as much of the work that we've already done. What's cool about this algorithm is that it's really flexible. We can obviously choose how many objects we want by just stopping the program when we reach the desired amount of objects. We can also choose exactly what objects we use. We can, for example, make it use only these glow objects, which has a really interesting effect. I'll get to generating videos in a second, but first, I want to talk a bit about how this was all made. To actually make this program, the first thing I had to do was get the textures for each object in the game. This is a lot harder than it may seem. Luckily, a friend of mine had already extracted all the textures for an earlier project of ours. I used Rust to make the program itself, and a GPU library to draw all the textures. Every object has a randomly generated position, rotation, and scale, but since we pretty much know that the best color is going to be the average color of the target image under the object, we can just calculate that instead of guessing it randomly. Much like a chameleon would probably do. This analogy is getting out of hand. Anyways, by doing about 500 objects at a time on the GPU and drawing them all as invisible in a fragment shader, I could do per pixel calculations like getting the average color and how well they fit simultaneously for all the pixels of each object, making the program a lot faster. Each time the program finishes making one object, it also generates the object string for that object, which is how Geometry Dash stores objects in levels. After it's done, the program puts all the object strings together into the Geometry Dash save file, so I can view the final product in-game. Okay, let's expand this algorithm to make videos. One thing we could do is use the image program we already have to make each frame of the video and then play them back one by one in the level. The problem with this is that because the image technique is based on randomness, the result will be really flickery and unpleasant to watch unless you use a lot of objects per frame and a lot of frames per second. I used a similar technique to make this Attack on Titan intro a while ago, and it uses like 1.25 million objects, which won't even load if you don't mod your game. And even with all those objects, it's still kind of flickery. The solution, again, is evolution. Evolution is not only good for improving creatures, but also for adapting them to new environments. If we create the first frame of the video using the technique we already have, the second frame is like a new environment to adapt to. We just let each object from the previous frame run a few more generations, where the children now survive based on how well they fit into the new frame. We also adjust their score based on how close they are to their ancestors in the previous frame, so it changes as little as possible. If the new frame is so different from the previous one that we can't make a new object fit, it dies out and we replace it with a new random object generated like we would for a single image. Now the video isn't flickery anymore, but we can still go further than this. If we only change the position and rotation of the new object and keep the scaling the same, we can use move triggers and rotation triggers to move and rotate the object smoothly to its next position. This also allows us to have less frames, since the movement is smooth either way. So again, I made my program do this, and here's the result. I think this looks great compared to previous techniques, and it's less laggy and more object efficient as well. The only downside is that it uses a lot of groups and colors, one for each object shown at once. But even then, you can still use the technique without the move and rotate triggers for an improved effect. So let's have some fun. Here's a video of my first Geometry Dash level in Geometry Dash. Here's a video of me editing this video in Geometry Dash. And here's a video recording of that video in Geometry Dash in Geometry Dash. And here's a clip from Shrek because more than 3 people have personally asked me to make this for some reason. So here you go. I hope this satisfies you, even though this is probably not what you meant. Now, I could probably have made this more efficient using deep learning and convolutional neural networks and stuff like that, but I have no idea how to do that, and this works well enough. Anyways, some of you are probably waiting for me to tell you where you can download this program so you can make the full Shrek movie inside of Geometry Dash or something. And to that I say, no, you can't. It's mine forever. Okay, bye.